equals to tan inverse of x. How do you solve for the derivative? Same idea applies. Now, your given question can be written as y equals to tan inverse multiplied by x. From indices, y equals to 1 over tan multiplied by x. Recall 1 over a is still the same thing as writing a raised to the power of minus 1. Similarly, tan inverse of 1 is still the same thing as writing 1 over tan. So that's what we just did here. Alright. From here, multiply, you have y is equals to x divided by tan. Cross multiply. By the time you cross multiply, you then have that x is equals to tan y. Call this equation 1. From equation 1, differentiate. By the time you differentiate, the x over dy is equals to sec square y. In this case, y is a function of x. Hence, by the time you differentiate, you have the x over dy. But initially, x is a function of y, meaning by the time you differentiate, the derivative becomes dy over dx. But in this case, we got the x over dy. Then how do I get dy over dx? Simply take the reciprocal of the left hand side and the reciprocal of the right hand side. Dy over dx is equals to 1 over sec square y. Solving for sec square y, from trig identity, sec square y is equals to 1 plus tan square y, right? Recall from equation 1, we have that x is equals to tan y. If x is equals to tan y, then x square is equals to tan square y. So therefore, sec square y, which is equals to 1 plus tan square y, can be written as 1 plus x squared, substituting the expression of equation 1. Meaning that dy over dx, which is equals to 1 over sec square y, is still the same thing as 1 over 1 plus x squared. And this comes to the end of this question. These are the final derivative of inverse function of tan. We differentiated sine inverse of x, cos inverse of x, and tan inverse of x. Given this function sine inverse of x, this is the derivative. Given this function cos inverse of x, this is the derivative. Similarly, given this function tan inverse of x, this becomes the derivative. So do well to check the previous video on cos inverse of x and sine inverse of x on how we got the derivative for each function. Alright, copy down this table because in calculation, when it comes to calculus, differentiation, you don't need to start showing the solution on how you got the derivative. You just need to recall. Recall your sine inverse, recall your cos inverse, recall your tan inverse, then you are good to go. Alright, see you in the next video.